All right, good morning. Thank you so much for watching. And today I'm going to be doing a brief introduction into the radicals. So this is the last lesson you'll be really needing for Algebra 1. And I'm probably going to be doing a little thing on the SAT and how you could do some problems for that after this. But yeah, so stick around for that for in next month probably I'll be posting that. But this is my last lesson for Algebra 1. So let's go. Let's get started. So what is a radical? So a radical is basically when we have some type of root, right? So in the past, you know what a square root of 25 is, right? We know that's 5 because when we multiply 5 times 5, it would give me this number right here, right? So basically the idea behind a radical is that it's simply saying to some type of root, we're going to be putting a bunch of numbers in to this. Okay, so we could have different types of roots, right? We could have things to the third root, right? So let's say I have the third root of 8, right? That'd be equal to 2 because 2 times 2 times 2 gives me this number of 8. So by the same reasoning right here, we can simply say that because we know the number 2 goes in here 3 times, therefore we know that it's the cubed root of 8. So now that we know what a radical is, now let's move on to how we simplify radicals. So a radical, to simplify it, what I would usually recommend you do is to write down all of the factors that go into the numbers that are inside this root right here. So we have right here 125n inside of the root. So to do this, what we're going to do is I'm going to write down every single number that can multiply to 125. So what you could do is a factor tree. If you've done this in elementary school, it's where you just take all the numbers and you put it into this little tree that breaks down. And when you multiply everything at the end of the tree, it would give you back this number right here inside of the root. So let's try it. Okay, so I'm going to write down 125n right here, and now let's break it down. So we know we can multiply 5, and if I multiply 5, that would leave me with, um, let's do this because it's easier to do in a calculator. It would leave me with 25, right? And then from there, 25 could break down into 5 and 5, right? So therefore we know what? We know that we have 5, 5, and 5, and of course we have this n we cannot forget about. So actually I'll include that in the thing right here. I'll break this down into n. So we know these are our roots of this number right here. So now what I'm going to do is because this is to this because it doesn't tell me what type of root we're doing. Because okay, let's look at this one right here. This one had the third root. This one was the second root, even though there was no number here that told me it's the second root. We can infer that it's going to be the second root because they didn't tell us. That's just the rule of how you write things in math. So right here for 125n, it's to the second root. So that means we're going to be looking at anything that when we have two of the same factors, it would go on the outside of the radical. So let's try it. So we know that the number 5 and 5 multiplies twice. Okay, well, it actually multiplies 3 times, right? But it repeats twice, right? So because it repeats twice, we'll put 5 on the outside of here. And then we'll put the radical and then everything else that we didn't highlight before. So this stuff right here, that would be on the inside of this radical. And that's it. That's really all you have to do to solve it. So when we do these radicals, all you have to remember is you're trying to find, when we're doing the second root, at least like in this problem, we're just trying to find the amount of times that all of we have the factors that repeat twice. And then if they repeat twice, we put that on the outside right there. So now that we know that, let's see how we can add and subtract the radicals. So right here, let's start off with this one. This one's a very straightforward one. We have 3 radical 6 plus 4 radical 6. So to add these, all we do is we just take the outer things right here and we add those up. So 7 radical 6 would be the answer. And we can do that because the radical is exactly the same for both of these. If the radical was different, we would have to simplify the radical. And then if possible, we could add them up. But it's not always able to do that. So be careful for that. So for this next one, 3 radical 18 minus 2 radical 2, it's going to be very similar. But the problem is we do not have the same exact roots right here, right? So to get them to be the same exact roots before I could simplify, we're going to take this and we're going to simplify that radical 18 and we'll see what happens. So I'm going to do a little factor tree right here. So we have 18, because I'm going to do my little factor tree for this radical right here. So I'm just going to do the stuff inside of the radical. So 18 could break down into 3 times 6, right? And then 6 could break down into 2 and 3. Okay, so off the bat, what do I notice? I notice that the number 3 is repeating twice, right? So because this number 3 is repeating twice, it would have to go on the outside of the radical. Okay, but here's the problem. There's already a 3 on the outside of the radical. So what can I do? I can since I was going to put this 3 from over here on the outside of the radical, now I'm just going to multiply another 3 right there on the outside. So it becomes 3 times 3 with a radical 18. Good. Oh, sorry, with the radical 2, because 2 is left right here. Good. And then we'll just do the rest of this. So this is just going to be 2 radical 2 from over there. And then now we're just going to simplify this. So 3 times 3 is 9. Oh, sorry about that. Sorry about that. It's going to be 9 radical 2 minus 2 radical 2, right? And then from there, now that we have common radicals right here, right? Now we could just subtract. So it'd be 9 minus 2, which is equal to 7, because we're just subtracting these numbers. So that's going to be equal to 7 radical 2. And that is my answer. That's not too bad. All you're just trying to do is simplify the radicals like I just showed you above in this previous example over here. And then using that, you can just add and subtract very simply. So now let's try to multiply radicals. Multiplying radicals are also pretty straightforward in my opinion. So let's try this. Okay, so we have radical 5 times radical 10. So since there's nothing on the outsides of these radicals, all we have to do for this is we just have to multiply stuff inside both the radicals. So 5 times 10 we know is 50, right? So this would be equal to the radical 50 because both of those were inside the radical. So we'd put the product of 5 and 10 inside the radical as well. So radical 50 is going to be the answer to that. But then we could simplify this technically, right? Because we could break down 50 into more smaller parts. So 50, I'll do my little factor tree again. 50 can break down into 5 and 10. And then, sorry about this. Okay. And then 10 could break down into 5 and 2, right? So 10 breaks down even further. Good. Okay, so now what we're going to do is we're going to figure out how can we break this down even further. Can we break it down further? No, we can't. So now from there, we can just look and say, okay, well, look, the number 5 is repeating twice, right? So therefore, that would go on the outside of my new radical. So it'd be equal to 5 on the outside. And then I'll put a radical, and then whatever's left would go on the inside. So it'd be just the 2 right there. And this is my answer, 5 radical 2. Not too bad. So again, very same premise as the previous ones I've done above. All you're going to be doing is multiplying everything over here at first, and then you're going to simplify like I taught you over here. But that's it. And then now we want to look at how do we divide radicals. So when we're dividing radicals, we're going to be using a very similar thing as well, because now we just have to make sure we know how to simplify everything before we divide. So let's look at this. We have 3 radical 20 divided by 2 radical 4. Okay, so for this one, let's just simplify everything first. So 3 radical 20. Can I simplify that further? Let's see. Let's try the radical 20. We'll take out this radical 20. I'll do my little factor tree over here. So we have number 20. And 20 could be broken down, let's say 5 and 4, right? Because those two multiply to 20. And then 4 can be broken down into 2 and 2, right? Okay. So the number 2 repeats twice. So 2 and 2 repeat over here. And then the outside would be, and the inside of the radical would be 5. So it'd be 2 radical 5. Good. So now, but the only problem is that I can't just put 2 radical 5 on the top here because I have a 3 still remaining, right? So I need to make sure I multiply this whole thing times the 3. So it'd be 3 times 2 radical 5 on the top, and then on the bottom, now let's just simplify the bottom. Okay, let's look at this. We have 2 radical 4. Well, hold up there. We know what 4 is. We know what a square root of 4 or a radical 4 is. We know that's equal to 2, right? Because 2 times 2 multiplies to 4. So I'm going to simplify this to become 2, right? That becomes 2. So this just becomes 2 times 2. So now from here, we're just going to simplify this expression even further. So the top would be 3 times 2 radical 5. And that simplifies to 6 radical 5 because we're just multiplying the outsides And on the bottom of this, 2 times 2 is 4. Okay, so are we done yet? No, because we have one more step to do. Notice how we have a 6 and a 4 over here, right? We have a 6 divided by 4. Can we simplify that into a smaller fraction? Yes. It can simplify even further into 3 radical 5 over 2. And then that's our answer. So notice how when I was dividing, I did not divide anything with the radical. I left the radical alone the entire time. And that is because when something's inside the radical, you cannot touch it when you're doing division. So when you're doing that type of division with these numbers over here. So if we're trying to divide, leave everything alone except for these, and you'll do the operations with these. All right, so that's our answer for that. That may have been a bit more complex, but it's basically taking everything I've just taught you, and now we're combining it into that. So now let's do one more example with division. I just want to show you guys a little thing you may see at some point. So you have radical 5 divided by radical 3. So so you may be struggling with that a bit, right? So let's just break this down a bit, right? We have radical 5 divided by radical 3. How do I break that down? Well, let's think. The problem with, I have not taught you this yet, but the problem with just simplifying this is that there's a radical on the bottom, and you can never have a radical on the bottom of a fraction in your final answer in anything in math. So we have to make sure we take the radical out of the bottom first. So whenever you see this, what you're going to want to do is you're going to want to multiply whatever radical is on the bottom on both the bottom and the top, and that would get rid of the radical. So what we're going to do is we're going to multiply radical 3 on the bottom and radical 3 on the top. Good. So radical 3 times radical 3 is just going to equal to 3. And that is, if you think about it logically, right? We have the square root of 3 times the square root of 3. The square roots would cancel out because we're multiplying it twice, right? Think of it this way, right? If I have radical 25 times radical 25, what would that equal? It would equal 25. Why would it equal 25? Well, let's just break it down, right? What does radical 25 equal? That equals 5, and then radical 25 equals 5. So that would multiply out to be 25, right? There you go. So by that same reasoning, going back to this example I'm showing you over here, radical 3 times radical 3 should get me to 3, right? So now that I know that, on the bottom of this fraction, we're just going to have a 3 right here. And then on the top of the fraction, we have radical 5 times radical 3. So we're going to multiply everything inside the radicals. So 5 times 3 is equal to 15, but that was happening inside of these radicals over here, right? So it'd be equal to radical 15. And then this would be our final answer. And we can't simplify radical 15 further because 15 would break down into just 5 and 3, and there's no number that is repeating. So there we go. That's our answer for that. Now we're going to do another thing that's going to be taking everything I just showed you and putting it all together. So we have 5 is equal to radical x plus 3. So now we're just doing a equation with radicals inside of it. This is a pretty basic equation, but we're going to try this out. So we have 5 equals radical x plus 3. So when we see a radical on one side and it's already simplified like that, we can just take the square root of both sides to get rid of the radical like I showed you over here. Because when you have a radical multiplying times itself twice, it just gets you everything that was inside the radical and it makes the radical disappear. So if I take the square root of both sides like this, it would equal to 25 is equal to x plus 3, right? And then you just subtract the 3 on both sides. So x is equal to 22. And that's the answer. That's all you have to do. So it's not too bad. You just have to make sure that we can get the radical by itself on one side, so we take the square root of the radical on both sides. So now let's do some practice examples. So pause the okay. Now pause the video. Try your best. See if you could do these, and then we'll come back and see how well you did. All right, so I hope you just tried them and did well. Let's see how you did. So let's start off with number 1. We have radical 45p squared. Okay, so this one, I am going to do a factor tree for to start off. So we're gonna have 45p squared, because that's the entire thing inside the radical, right? So 45 could break down into 9 times 5, and I'm just gonna leave the p squared over here. Or actually, I'll break down the p into p times p, right? Because technically, p times p would get me to p squared. Okay, and then from there, we'll have 9 breaks down into 3 times 3. Okay, so now let's look at this and see what, because we've simplified everything in this factor tree, what is repeating. So we have 3 times 3 repeating, and we have p times p repeating. Good. Okay, so basically we're going to put 3p on the outside of our radical, right? And then what's remaining? The 5, right? This 5 right here is the only thing that's left. So we put the 5 over here, and that'd be our answer right there. That was it. Not too bad at all. Now let's do number 2. Negative 2 radical 3 plus 3 radical 27. How do we break that down? Well, okay, so this radical is simplified because I don't think I could do anything further with that, because 3, there's nothing I can really simplify with 3. But 27, I think it's possible that if I take the 27, I could break that down into something further, and that could help me to simplify it eventually. So let's try it. So I'm going to put my factor tree over here, 27. Let me try it. Okay, 27, and then you have 3 times 3, no, 3 times 9, right? So 3 times 9 would give me a 27, and then 9 would break down to 3 times 3. Good. So now it's repeating the 3's, right? So because this is to a square root, we're going to be doing, just looking for 2 of the 3's. Okay, so we have 2 3's right here repeating, and then we have 1 extra 3 remaining. So this whole thing would become 3 times the 3 from that with a radical of 3. And then that would simplify to 9 radical 3. And okay, just to be clear, this 3 I was using for that, and then these 3's combined to that 1 3 over there. Okay, so now from here, we have to also add in this whole section right here, right? So it'd be negative 2 radical 3 plus 9 radical 3. And then how do we simplify that? It would be negative 2 plus 9, because we're just doing these parts right here. So that'd be 7 with radical 3. And that was easy to do because we had these common square roots right there. All right, let's go to number 3 now. Number 3, we have negative 4 radical 15 times negative radical 3. Okay, so how do I do that? Well, let's think. Okay, so let's multiply everything inside the radicals first. Okay, actually, okay, I'll do the outsides and then the insides. So on the outsides, we have negative 4 times negative 1, right? So that just becomes positive 4. Okay, now on the insides of my radicals, I have 5. I have a 15 times 3. Okay, so that would become 45, right? Radical 45, because that's what's happening inside these radicals. Okay, now can I simplify this? Maybe, because I have a radical 45 right here, and 45 could potentially break down into something smaller. So we have 45 right here, and I would break down, let's say, 9 times 5 multiplies, right? So 9 times 5, good, and then 9 can break down into 3 times 3. Okay, so we notice that the number 3 is repeating over here twice. So that would go on the outside. We're going to move a 3 to the outside of my radical now. So it become 4 times 3 with a radical 5. Good. And that simplifies now to 12 radical 5. And then that would be my answer. Okay, so that's the answer for that. Now let's do number 4. Number 4, we have radical 2 divided by 2 radical 3. Okay, so remember the rule I told you guys where you can't, when in your final answer, you cannot have a radical in the bottom of a fraction. So we're going to use that rule now to help us. So to get rid of the radical 3 on the bottom, I'm going to multiply the bottom times 2 radical 3. And I'll multiply the top times 2 radical 3, because what you do to the bottom also has to be done to the top. Okay, so now this would become, and here's where it gets fun, because I haven't showed you guys this yet, so you may have struggled with this part right here. But to do this, we have to multiply the outside, right? So 2 times 2, which is just 4, right? And then now we have to multiply the insides of the radicals. But we had, okay, so radical 3 times radical 3. Okay, well, that's radical 9, right? But then radical 9 would simplify into just 3. So that would just become 4 times 3. So in other words, as I showed you guys before, when you have a radical times a radical, it just gives you the number that was inside the radical. It's the same exact number that's being multiplied for those radicals. And now let's do the top. So we have radical 2 times 2 radical 3. Okay, so it's on the outside, we'll put the 2 because that's the only number we're given that's on the outside. And on the inside, we have a radical 2 times a radical 3, which becomes radical 6. And we're going to simplify this now, so it becomes 2 radical 6 divided by 4 times 3, which is 12. And then remember, we have to simplify our fraction now. We cannot include the radical when we're simplifying the fraction. So we're just going to find the fraction of 2 over 12, which is equal to 1 over 6. So 1 radical 6 over 12. So in other words, that's the same thing as saying radical 6 over 12. And that is our answer for that. Let's do one more example and then we'll be good to go. So this is our equation with the radicals. So let's just try this. Okay, so we have 1 equals to radical x minus 5. Okay, so since the radical is by itself on one side, we could just square root both sides and then solve from there. So when we take the square root of this and the square root of this, we'd be left with 1 is equal to x minus 5. And that's because the radical of something repeated, the radical of the same thing multiplied twice is just going to be the same thing as the stuff inside that radical. Okay, so from there, we would want to add the 5 onto both sides. So plus 5 and plus 5. So it'd give me to 6 is equal to x. And that is our answer. All right, so that's it. Thank you so much for watching.